Okay, sometimes it goes south on me when I do this when I include the thing. But anyway, I just wanted to. I'll probably announce. I've already said this in class, but what I'm going to start doing, I'm just going to make because it takes a lot of my time and I, I don't know if it's been helpful, but I do know that just getting a push in the right direction on homework is also very helpful, so that you're not overwhelmed or don't feel overwhelmed by what's going, by getting the homework done, which is where you can really make a lot of good points. So anyway, that's what I'm going to do. I'm going to pick 3 problems from the homework, and that'll be your video for this week. And I'm going to start doing the same thing for 210, and it'll make my life easier, and I think it'll be more beneficial for you all. Anyway, so let's take a look at a couple of these problems that are up here. All right, first of all, and so I'm still going to make several copies of them. So let's take a look at physics at problem 20, because I think we've already beat the other ones to death, and let's make sure we've got this. All right, so now we're talking about generators. Okay, so this is a generator. All right, and let's go back to the original equations, and then I'll stop this little movie, record video 1, and we'll continue with this problem. Okay, so let me write this down first of all, so that you can kind of get this. See, it's these delays. I shouldn't have one here. All right, let's move this out. Okay, so here's the deal. You know that a Weber, or Weber, and not the grill, is equal to the number of, well, basically BA times the cosine of the angle. All right, and we know that the change over time of this is equal to an EMF. All right. So what if we want a constant EMF? What would we do? Well, first of all, we would have a machine that would take mechanical energy and start spinning this thing so that that angle is changing all the time. Because this is what we want. Constant change, instantaneous constant change, which will equal an EMF. An EMF that's ongoing but always changing. Okay? All right. So here's what so if you take d5 dt, first of all, do you remember that theta was equal to omega times t? Its rotation time, remember that? All right, little calculus here. So d5 dt, if we take the derivative of this thing, where we're taking the derivative of b a cosine of omega t, well, guess what? We're taking the derivative. These guys are constants, so they come out, and we wind up with BA times any derivative of the cosine is minus the sine of sine omega t. But wait, got to do the chain rule. Got to take the derivative of what's inside with respect to t, so I wind up with omega. Okay, so I wind up with BA omega sine of omega t. Now, when t is at 90 degrees, when this is at a maximum, when omega t is at a maximum, then E naught, my maximum voltage, is equal to BA times omega. Now, we also learned that omega is equal to 2 pi f. So my maximum voltage is equal to BA times 2 pi times the frequency. All right, that's my maximum. And this thing will fluctuate sine curvy. And I can also always shift it over. I can make it a cosine curve if I wanted. If I wanted to start here, I can make it a cosine curve. All I got to do is just shift it 90 degrees. All right? So that's your first experiment. So that'll get us started on this problem.